Meeting is being streamed live on YouTube. I'll send the link to us shortly. Okay. Sorry for the delay. The traffic today was a bit much. So while we are waiting for others to join, so let me share the link. So the link for yeah, I just saw someone's message that I promised to share the last slide. Yes, that is true. Why I actually didn't share the slides is because so I want to believe everyone can see my screen. Can you see my screen? Please reply via the chat if you can see my screen. Okay, all right, thank you. Please help to circulate the link. Help to circulate the link for the YouTube session. So for some of your colleagues that might not be able to join us on Zoom because of the limited capacity, so you can share the link to them, all right? So you can share it with them. I can remember last week. So today's class will be more of practical. I can remember we solved some questions last week, but today's class will be more of practicals because there are two important aspects that we need to cover. So I think this was where we stopped last week. All right. So today we'll be looking at control structures. All right. We'll be looking at control structures in Visual Basic. So it's not just in Visual Basic, we have control structures in almost all the programming languages. In fact, all the programming languages. You have it in Java, you have it in Python, you have it in C Sharp, C, just name the programming language. But what is just different, like I mentioned last week, is the fact that each of them has its own syntax. So once you're able to understand the syntax for a particular programming language, I don't think you should have any issue with the control structures of that programming language. So it basically has to do with how the program flows. Do you get it? So how does the program flow, the control of the flow of the what of the program. So Visual Basic, just like any other programming language, executes instructions in three ways. You're talking about Python, you're talking about Java, talking about any other programming languages. Most of them have this what? Have these three basic control structures. We have what called the sequence structure. We have what is called the session repetition. So we have what is called the looping or the what repetition structure. So I want to believe everyone can hear me before I start the class properly. So let me see. Okay, we have some of us that are watching on YouTube already. So let's go back to. Okay, all right. Thank you for the response. All right, so I said we have three structures to look at. We have the sequence, we have the selection, and we have what looping. When we talk about the sequence structure, from the name sequence, it actually has to do with what sequential execution of instructions. So when you talk about sequence structure, one thing you should know about here is that this structure allows instructions to be executed one after the other. Yes, if you can recollect, if you look at some of the programs that we wrote last week, I think we wrote one to find the area and circumference of a circle. There's what is called structure in every program. Now, looking at that program, remember I told us that before we could say that I want to find the area or circumference of a circle, the first thing is to make sure that, okay, we have our pi ready and we have our radius ready. If you can remember, when we wrote the program, we definitely need our radius. So we had to first of all declare able to calculate the circumference and area of a circle. That is what is called sequence. For me to calculate my circumference, I need radius. That means I have to get that first. I won't say circumference is equal to what? 2 pi r. Then after that, I'll now get my radius. It doesn't make sense. It doesn't flow that way. I must get my radius before I can what? Calculate the circumference. And it's after I calculate the circumference that I can get my output. I can display my output. So I don't display my output before I get my input. You get it? So that's to tell you that your instructions will be executed. I'm making my declaration the last statement. No. If your variable is going to be needed anywhere in the program, that variable must first of all be declared before it can be used in that program. So that's it about sequence. Instructions in VB are executed in a sequential manner. So let's look at the selection structure. Yeah. So this structure involves choosing instructions to execute out of two or more alternatives, depending on the value of an expression or the outcome of what logical test. From here, selection. When you say select, that means that you have two or more options, but you can actually make a choice. While you were trying to apply to University of Lagos, we had so many courses, right? We have so many faculties, but each of you decided that no, this is the faculty that I want to choose. You made a choice. That's a selection. And even apart from the fact that you decided to choose faculty of science, different people still belong to to different departments. So at that point in time, what you did is what you made another selection. I want to be in computer science. Yes, it's still in the faculty of science. I want to be in microbiology. I want to be in zoology, I want to be in this department or that department. You had many alternatives, right? But you had to select one of the what available options. So that's the same way we have that's the same way the selection structure works. Selection, it involves choosing instructions to execute out of two or more alternatives, depending on the value of what of an expression or the outcome of what of the logical test. And now, depending on something, for those of us that chose Faculty of Science or Faculty of Engineering, it is expected that maybe while you were in secondary school, you must have been in science class. Do you get it? So that is the value of the expression. If what? If secondary class, by secondary class, I mean either science or arts or commercial, if secondary class equals to science, then I can belong to a department in what? In science or engineering. Do you get it? If department is arts, then I can belong to faculty of arts or other faculties that offer art courses. So that's what we mean by what? Selection. So we'll see VB programs where we have one or two options to make. For example, you have an umbrella and you take the umbrella out depending on the what on the weather of the day or on how the weather condition is. If it is raining, that is an expression. If it is raining, instruction is please take out your umbrella. Else, that is another option. If that means if it is not raining, if it is raining, please take out the umbrella. Else, meaning if it is not raining, you don't need the what? The umbrella. Here we have two options to make. Is it raining? If yes, there is a there is an instruction for you to execute. Take the if it is not raining, that means there is no need for you to take. So do that when you select only one instruction to execute from two possible choices. Depending upon, remember we said there is always an expression, depending upon whether the Boolean expression is true or false, or from several possible choices, we said either two or more, all right, or from several possible choices, depending upon the what of the value of the specified variable. We have examples that will be showing us in this class. Whereas looping, I'm just trying to introduce the three control structures to us before I now start to treat each of them individually or separately. So when you say looping, looping involves the execution of a set of instructions repeatedly until some particular condition has been satisfied. So when you say looping, we have what is called conditional looping or unconditional looping. Conditional looping means the statements are repeatedly okay. Looping, your instructions are repeatedly executed until what some condition is satisfied. Now, let's see selection. Just as I've mentioned earlier, selection allows the computer to choose the instructions to what to execute. Other instructions may be ignored. The term selection is used properly for a choice made from many possible alternatives. While the choice made between two alternatives is referred to as branching. So now let's look at the kind of selection options that we have in a Visual Basic. In Visual Basic, we have what is called the if-then statement. In VB, the if-then block statement is used to execute a single statement or a block of statements on a conditional basis. Without wasting much time on that, so let's see what it looks like. So on this slide, you can see we have two forms of the statement. If this, do you get it? Then do this. So that's how I always interpret it. If this condition is true, then this is what I want you to do. So you can see we have two forms, form one and form two. If logical expression, maybe I'm writing a program that says enter your name. All right. So I want to check if name equals to Abass, then Abass is a lecturer. You can see if name equals to Abass, name equals to Abass is something that I'm trying to check. Is the name equal to Abass? That is a logical what expression, and it can return one of two possible values, true or what or false. If logical expression, if name equals to what Abass, then executable statement, whatever I want the program to do, if that condition is true. If name equals to Abass, then write or print, welcome, Mr. Abass. You are from the Department of Computer Science. You are a lecturer there, you are this. So those are the statements that I have under the what? Under that logical expression. So the other way I can write it, or VB allows me to write it is, you can write if, then you put your logical expression, then if, then after if, your if must be followed by your logical expression. And after this, it must be followed by what? A then statement. Sorry, the then keyword. So after this then keyword, you have all the statements that you have under that condition. And in the end, once you are through with the statement, then you put end if. It is the syntax of Visual Basic, so you cannot change it. If, put your logical expression after if, then put then. That is the syntax. You cannot change it. And once after your then, you write your executable statements. Those are the statements that come under the condition. And after that, you have end if. So those are the two forms. So let's see an example. Write an if-then statement for this situation. Yes, you have to remember you can write a program where you have to make a choice from many choices. You have to make a selection from many possible choices. Now look at this. Write an if-then statement for this situation. If salary collected is greater than 10,000, the tax payable is 10%. From this, before you can say you can decide on whether you are working with a selection, just look at it. Am I making a choice? Yes. If salary is greater than 10,000, the tax you are to pay is what? Is 10%. So you can see the VB code that I have here. So if I'm to interpret this in Visual Basic, remember I told you that after if, what follows if is what? Is a logical expression. So salary greater than 100 is the logical expression because we are trying to check, is this true? So if salary is greater than 100, remember I told you that once you've written your logical expression, what follows that is the then keyword. You cannot change it. If salary is greater than 10,000, then what should you do? The statement I have here is what? My tax is what? Is 0.1 times 10,000. And remember, I told you that once you are through with your statement, I can have more statements under that condition. Any statement that I want to have, I can keep adding. But what this wants me to do is just to what? To make sure that the tax is what? 10% of the salary. Once the salary is greater than 10,000. And after that, what happens? And if. I told us that is the syntax. Please, I want all videos to be turned off. All videos to be turned off. Azizat Ajao, Oladele Olakunle, please turn off your videos. That works. Just write simple code. So here we have a command button. I told us what you know what the command button does. Because I'm in my screen, because the screen from here, yes, so I can see it clearer now. Okay, so let me share my screen again. So, so now just see how the if statement work. So label, I told us that it has a caption property, so I can change that. So let's say enter tax, all right? Enter tax. Hello, I believe you can see my screen. So enter tax. So we have a text box to receive the value of the tax. We have that. So, and I want the tax payable to be displayed somewhere. So now let's say I have, thank you for the response. So I have tax is, so let me change the caption to tell me what my tax is. Tax is, so now remember, I've been showing our outputs using text box. You can also show your output using the what? The label. So all you just need to do is you set the caption of the label to whatever your output is going to be. So in this class, I'll show us both. We used text box last week. So now for this, let me still use a text box. Maybe after this, the next one, then I'll use a label to display the output. So we have this, so I have another text box too to display my output. I've cleared the text value. So now this button called command one, it has a caption option. So let me change it. So let me say calculate tax. My help button is not working. So let me just calculate tax. So we have calculate tax, calculate tax. Okay, we have that. And remember, I said when you want to write a code, you click you double click on the command button, then it will bring this. You don't need to clear the code section that appears. All you just need to do is what? Write your code. We need something to receive the value of your salary. So we can say dim salary as single, dim salary as. Why is our salary single? Because our salary can have a decimal point. It can be 100,000 dot this. And remember, we have some people that collect millions. So we can decide that for it to be able to receive a very big value, we can make it double. So I've changed it to double. So it will be able to take any salary, any value for your salary. Now the next thing is you want to calculate tax. So our tax too can have a double value. So I can decide that okay, let me deem my tax. Let me deem my tax as I can say dim tax as single or double, whichever one. So dim tax as what? As single because I have to calculate a tax value. So it's important for me to also declare the type of my what of my tax value. So the next thing is to calculate the value of my tax. So my and yes, I can't calculate the value of my tax yet because I've not received the value of my salary. For me to calculate my tax, I must receive the value of my salary. And remember, the value of my salary is to be entered in what? In text box one. So I have salary, I have salary equal to what? 10%, that's 0.1. 10% is 0.1. 10% of my tax is what? 10% of my salary. So this is tax. Tax is 10% of my salary. That's 0.1 times what? Times salary. So tax is 0.1 times salary. I've calculated my tax. The next thing is for me to display the value of my tax. Remember, I have another, okay, salary. What is salary? Salary is what I enter in my what? In my text one. So text one dot what? Text. That's whatever I enter, there is my salary. And this is going to use the value enter the text one is equal to salary. So the value here as salary would come here. So now I've calculated my tax. The next thing is for me to what? To display the value of my tax. Remember, I created a text box. The text box is, so this is where I want to display my output. So let me see the name. You can see the name is what? Text 2. So let me go back to the code. So text 2, text 2 dot text, that's the value that should appear in text 2, is what I calculated as tax. Now, I have not even fulfilled. Let me go back to the question. This one is just, what this is just doing is what? It's calculating 10% of whatever salary that you get. But remember, there is a condition there that if salary is greater than 10,000. So now let's put that condition. Salary here is what? Is received here. So I have to say, if my salary, now the if statement is coming, because the 10% of your salary should only be calculated for tax if what? If that salary is greater than 10,000. So now I have if, that's my condition. And I told you, after your if, what follows is your logical expression. So I have salary. If salary is what? If salary is greater, they didn't say greater than or equal to, they said greater than 10,000. All right. I told you, after your expression, what follows is what? Then. If you fail to put your then your program is going to what? Is going to give you an error. So if salary, then what should happen? Calculate tax as 10% of the salary. So that's the only thing that I want to do. So once I'm through with that, end if. All right. So that is just a single option. They didn't tell us what will happen or what should happen if the salary is less than 10,000. They just said if it is greater than 10,000, then your tax is what? Is 0.1 or 10% of your salary. So that's what we have calculated here. So if salary is greater than 10,000, salary greater than 10,000 is my expression. And they said after your expression, what follows is what? A then. It's a keyword. You can't change it. After then is what? Whatever you want to happen. So what I want to happen is to make my tax 10% of my salary. That is the only statement that we have there. That does not mean that we can have just one statement. We can have as many statements as possible. But that's the only thing they want us to do, to calculate tax as 10% of the what? Of the salary. All right. So after that has been calculated, the value of the tax calculated should appear in my text 2 or text box 2. So that's what I'm doing here. That the value of my what? Of my tax should appear in text 2 dot text. All right. So now let's see this to see if there's any mistake in the program. Um, you don't have to write a perfect program. Yes, even me, I might not be able to write a perfect program. Don't just, because sometimes it is possible as a programmer to make a mistake. Do you get it? So you can debug your program. It's going to reveal whatever errors that you have in your program. So if I try to run this program and there's an error, like it's some of the programs that I wrote last week, so you would see it will give me to tell me there's an error. And at that point where there's an error, you would see the cursor blinking at that point. So now let's try to run it. If there is no error, it should run normally. So now enter tax. Let's say the tax is 120,000 and 10% of 120,000 is 12,000, right? So now let's calculate tax. You can see calculate tax. Tax is what? 12,000. All right. So now that is greater than 10,000. Let's enter another value. Let's say 10,000. Now let's calculate tax. You can see tax is zero. It didn't calculate the value for tax. Why? Because we said if salary is greater than 10,000. Why you have tax at zero is for your numbers. We have declared tax as what? As single, which is a number. So once you are not giving a value for your number or it's not being calculated, there's a default value that is assigned to it, and that is what? Zero. So that's why you can see, because 10,000 is not greater than 10,000. Because the condition for calculating 10% of the salary is what? Is if that salary is greater than 10,000. And here we entered 10,000, and 10,000 is not greater than 10,000. That's why you can see that it's giving us the default value of a single variable, which is what? Zero. So that zero is not actually the real value calculated. It's not calculating any value. That's why you have zero there. So now let me change it to 10,001. You see 10,001 is already greater than 10,000. You see that it's going to calculate the exact tax from 10,001. You can see 10,001. The tax is what? 1,000.1 because tax is 10% if that value is greater than 10,000. It being I said greater than or equal to 10,000, that means from someone collecting 10,000 and upward. You see that the value for the tax will no longer be what? Will no longer be zero when I enter, let me say greater than or equal to. Okay, I have to close that. If you don't close it, you cannot change the program. So I've closed it. Now I can change it greater than or equal to. So let me run. You see that 10,000 will no longer give us zero here. It will give us 1,000. You can see it's giving us 1,000 because it is greater than or equal to, meaning that it can be equal to 1,000 or greater than it. But when you say greater than 1,000, greater than 10,000 and you enter 10,000, because 10,000 is not greater than 10,000, so you will not calculate 10% of the what of the tax. So this is just the program to execute what we have here. All right. So this is another one. If sex is equal to male, that's your gender. If sex is equal to male, then it should tell you to what to go to school. So we have two variables here. Sex is a variable. We have message, which is also what a variable. So I believe we should be able to attend to this because it's just similar with what we wrote here. So just see if that means there should be something to take the value of sex from you. Then is it male? If it is male, this is what should happen. If it is female, there's no option for that. So this is just a single statement. So we have if then statement. That's just it gives you only one part of execution. There is no another path. But the if then else gives you another option. If this, do this, else do this. You can see that means you have two options. If department is equal to computer science, say you must be a programmer. Else, if you wish, you can learn programming. You can see there we have two options. In the previous one, if department is computer science, do this. If you belong to a different department, nothing happens. But here, if then else, permit one of two groups of executable statements to be executed, depending on the outcome of the logical text. So the syntax for if then else statement is just as we have it for the if then. If logical expression, then do this. All right, you can have one or more statements. Else, that means if that logical expression is false, if it is not true, else this is what I want you to do. So now let's still use this, the last program that we wrote for that. So now let's still use the last program and see. You can see, so if logical expression, then this is what I want you to do. Else, this is what I want you to do. And it ends with what? With end if, just as the previous one ended with end if. So now let's see this. If salary is greater than 10,000, tax is what? 10%. Else, meaning that if it's not greater than 10,000, you can see. Remember when we entered 10,000, then nothing happened because there is else. Else now, you see that something be done. Else, tax is equal to what? Make my tax. If your salary is greater than 10,000, tax is 10%. But if it is less than that, your tax should be, let's say 5%. So 5% is 0.05, okay, times the salary. That's whatever the salary is. If it is greater than 10,000, make the tax 10%. Else, make the tax 5%. So now let's see, let's enter 10,000 there. 10,000 is not greater than 10,000. That means the tax that will be calculated for that is 5%. Whereas in the previous one, because we didn't have two possible options, it didn't calculate any tax. But yeah, we now have two options. Anything not greater than 10,000, we go for else. So the tax is going to be what? 5%. Now let's see if that is true. If I enter 100,000, the tax should be 10%. That's 10,000. That's correct. So if I enter 5,000, 5,000 is not greater than 10,000. So the tax should be 5%. And 5% of 5,000 should be 250. Yes, correct. So we have 250. Now let me enter 10,000. There, 10,000 gave us zero. But because we now have another option that if the salary is not greater than 10,000, make my tax 5%. So if I enter 10,000 there, it will calculate 5% of it. You can see 500. Whereas if, because we now have two options, if it is greater than 10,000, this is what you will do. If it is not greater than that, this is what you should do. So now, if then else allows us to make what? One of two possible options. If then is just one option. If this is what you should do. If it is not, if that condition is not true, nothing happens because you have not made any provision for the what? For the else part of that condition. But if this, do this, else, that tells you that what? There's another option. Else, that means if that condition is false, else, do this. So you have two options. All right, before I proceed, um, is I clear or can you understand all I've been saying since? So if you understand, please just put yes on the chat group. Okay. So that means I'm not talking to myself. Thank you. So now we have apart from if then else is just two options, either this or this. If then is one option, you are not making any provision for another option. If this, do this. If sex is male, go to school. That means if sex is something else, you are not telling us what should happen. But if sex is male, go to school. Else, else, I don't want to offend the ladies. Else what? Is it only guys that should go to school? Else. Go to the kitchen. So if you are male, go to school. Else you can see two options. That means if it is not male, go to the kitchen. It's not male, it's from Buhari. So you should understand my message. All right, so apart from that, let's see what we have again. If then else is two options. So this is an example. I think we just wrote one as well. If flag is true, then drink is equal to what? Hot tea. I can say I can write a code that will ask you for today's weather. Is it hot or cold or cool? So if you say the weather is hot, it will tell you please drink ice water. Else, meaning that if the weather is not hot, that's the meaning of else. But you don't have to, when you write else, you don't have to put the condition again. Because else means if that thing is not true. So you don't have to put a logical expression for else. Else, that means that is the other alternative of your logical expression. Else, do this. So if flag is true, then drink hot tea. Else, drink ice water. So look at the statement. Write an if then else statement that will set a string variable called drink to hot tea if the Boolean variable flag is true. Boolean variable flag is true. That's my logical expression. Or ice water otherwise, you can see. Otherwise means you don't have to now say if it is false. Otherwise already means if it is false. So you don't have to put a logical expression for your else statement. Also, if you have more than two choices or you have more than two options, you can now introduce what you call the if then else if else. If I have just three options, if else if and else can suffice for that. If I have four options, if else if another else if else, that is four. All right. So the else if can be repeated depending on the number of options that you have. It can be what? Repeated depending on the number of options that we have. If I have just three, if is for one option, else if is for another option, else is for what? Another option. If I have four, if, else if, else if, else. I have four there, right? So if I have more than four or five, six, seven, blah blah blah. So just for me to keep adding else if, else if, else if, else if, else if, and the last one is going to be what? Else. And the else is only executed if all those other previous logical expressions are false. If Okay, I think I have an example for that. Or if there's no example, we will still use the same code that I've been working on. So I'll just formulate a question now, and we'll use that to see how we can make a choice from several alternatives. So write a VB code that will take in a number 1 through 7 and print out day of the week. Write a VB code that will take in a number 1 through 7. Please just give me a minute. Hello, ma. Yes, ma. Please, ma'am. All right. So write a VB code that will take in a number 1 through 7 and print out day of the week. Um, so you can see here we have many options. That means it will take in a number 1 through 7. If it takes in number 1, it will print out day of the week. That means if it will ask you to enter a number, once you enter a number, it will check. Is what you entered 1? If number is equal to 1, then print Monday. Else if, because I told you we have several options, else if number is equal to 2, then what? Print Tuesday. If this is this, print. So now let me just quickly write that. So I want us to see how that is done. So when we have several options, we can't use if then. We can't use if then else because it is true. So we go for what? If, else, if, then, of which, of course, we know else if can be repeated any number of times depending on the number of options that you want to make available to the user. So now let's quickly write a program to do that. So, well, if you go through the video again, you will see this code because I don't want to create another form for that. Okay, let me just save this and I don't want to create another form for that. So let me edit this. It should tell us to enter a day, all right? Okay, so let's change this. Enter day. So enter day. Enter day. So this should receive the value of the day from us. So it should print day is. So today is. So whatever we want. I told us I will use label for the next output. So now I've cleared that text box. So let me use a label. How do we use a label for output? So let's see that. So I will remove the caption because I want it to be empty so that I can display my output. All right. So this has a wrong caption. So I can say what day, what day, what day. So now what day, I have to clear the code. So you can see enter day. It should receive the value of a day from us according to the program. So let's say dim day as what? As integer because 1, 2, 3 they are all integer values. So dim day as integer. So day is what? The value that is entered. So the day as integer, day is what? The value that is entered in my text box. So val. Now what text box is this? Text 1. All right. So now I can go back to the code. Text 1 dot text. So that will receive the value of day. So the next thing is what? Is to check for the value that has been received. If day, remember when we treated the relational operators, we listed several relational operators. We talked about the what? We said the relational operator is also known as the comparison operator. And we listed all the operators. We can have greater than, we have less than, we have not equal to, we have equal to, greater than equal to, less than equal to, and more. So these are the relational operators that we have. So if they, remember I told us that the equal to Equality operator is just a single equal to symbol, all right? If they equal to 1, all right, then what happens? Then I can say this is label, right? Label 3, okay, label 3. So if that label 3, that means change. Remember that label has a caption property. Label 3 dot caption. What is the caption? That is, what should you attach to label 3? Label 3 dot caption is equal to what? Is equal to Monday. So I want one to be Monday. That's if day is equal to 1. Else if, because I have many options, else if there must be a condition, day equal to 2. Can you see? Then what happens? The caption should be what? Tuesday. That means label 3 dot caption should be Tuesday. Label 3 dot caption should be what? Tuesday. Tuesday. How? Else if, maybe what I entered is 3. Else if day equal to 3, then what should happen? My caption should be what? Wednesday. Today is Wednesday. So today is Wednesday. I have another, okay. So let me just copy this because this will keep repeating. So if it is 4, if day is equal to 4, if day is equal to 4, then the caption should be what? Thursday. Thursday. If the caption is 5, if day equals to 5, it should tell you it is Friday. So the caption for, if we were using text box, it would have been dot caption, it would have been dot text, because the property that allows your text box to display something to the user, or is, do you get it, is what? Text. Text, this dot text. But in the case of label is caption. That's the caption for that what? Label. So we have Friday. Else if day is equal to 6, that means if what I entered is 6, then label 3 dot caption is Saturday. We have Saturday. If it is 7, then we have Sunday. Sunday. Remember, we said there should be else. I can now introduce else, meaning that if you now enter a value that is not any of these, else, meaning that if there is not 1, if you didn't enter 2, you didn't enter 3, 4, 5, 6 to 7, else meaning if it is none of this, because there must be a value, and depending on what you entered, that will determine the what? That will determine the value, or that will determine the statements that will be what? Executed. Else meaning that if all this have not been done, so label 3 dot caption, I can now say label 3 dot caption, so it's equal to what? Invalid. Maybe it will tell you that invalid. That means that you have entered an invalid number. It can be anything. So remember at the end, I said there is end if, right? End if. So meaning that the whole of this if that we started here is ending here. So that's the meaning. Every if must be what? Ended. So every if must be what? Ended. Else it will give you an error. So all the else if, blah blah blah, they all come before end if. So now let's run this to see if we have any error. So now let's run. Enter day. If it is 1, today is Monday. Can you see that? So now let's okay, let me introduce a clear button so that I won't have to be going back to the code. So let me have a clear button, a command button called clear. So let me have so let me change the caption. Just like your label, it has a caption property. All right. So clear, what should clear do? It should set the value in my text one to empty and make my label empty. So that's text one dot text. Text one dot text is equal to empty. And also I want it to change the value of my label to empty. So label three dot caption equal to what? Empty. You see that for label 3, I didn't put label 3 dot text because label does not have the text what? Text caption. It has the what? Sorry, text property. Its own is what? Caption. So I have that. So I think we are good to go. So now let's rerun it. So enter 2. 5 is Friday. What day? Friday. I can clear now. You can see. So I don't have to start going back to this thing to close it ahead. So enter there. If I enter 7, 7 you can see for 7 possible options, 1 through 7. All right. Meaning that if I enter a value that is not part of my what logical expressions, I already said that what the caption should have a label. Label 3 should have invalid as its caption. Let me enter 8 and let's see what happens. So 8, what for that? All right, before I proceed, I will still following, still following. Please, are we still following? Can you hear me? Sir, can you tutor me on this FSC, please? How many students do I want to tutor? I said, can you hear me? You said yes, sir. And I asked, are you following? You didn't reply. For like 2 minutes, I was waiting, no response. Can you hear me? They said, yes, sir, yes, sir, yes, sir. Yes, you can hear me. So are we following? No, sir. So you can only hear me, you are not following. I don't know what your yes means. Is it that you are following or you are just hearing? Which of the two? You can only hear, you are not following. Or yes, we are following. Okay, okay. All right, thank you. You can't see my screen. My screen is still being shared. I believe you can see my screen now. I'm still sharing my screen. You can see me, self. You are not serious. All right. Some of us are following while some of us have some, but we still have a lot to cover. So we'll see what I can do regards that. All right. So we also have as an alternative to what? To the if then else if blah 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 else. We also have what is called the select case structure. This structure, just like what we have seen, the last if then else structure. This structure is a variable or expression and allows the choices to match its possible values. Usually, a default what is specified in case with the last one that we wrote. So instead of having the what, if then, else if else, do you get it? You can also use then the various cases of the what, of the variable, you list them. Then finally you have case else, that's if all the values are false. That's what is the next case for that. Don't worry. Just as I promised last week, I will share the link for the last week's lecture. I will share the link on. I will share the link to you guys. You guys, and the link, the YouTube link for this current lecture. So I would also share it, so you can probably download the video and watch later to understand some of the things that I've been teaching. So now let's use select case and see how it works. So this same program that we wrote, let's use the select case for it. So I can, if I don't want to use the else if else, I can also use the what, the select case. So now let's see how that works. Instead of saying if day equals to 1, now let me show you. So okay, let me just erase the whole of this so it doesn't appear confusing to you. All right, so this is where I want to make my decision. So I have select case. So the variable that you want to use for the selection is day, because day can have several values. Select case day. Don't forget to end that select. Just if you write, if you have if, you have to end if. So you have select case. The variable that you want to what, to use for the selection is day, because they can have different values. So now next thing is case. I'm making day my case. Case 1, meaning that if it is what, 1, case 1, if it is 1, label 3 dot caption, the 3 dot caption equals to what? Label 3 okay, if it is 1, Monday. That's the same thing as if day is equal to 1. Remember for the last one we said if day is equal to 1, then, right? So just for us to remember the syntax, you can see select case variable. That's why I said select case day. And after that variable, all the various cases that you can have. Case variable value 1, that's that variable can have 1, day can be 1, can be 2. Do you get? Those are my variable values. And in the end, we have case else. So this is the syntax I'm following. So you can see the way the syntax is here. That's what we are trying to what, replicate. So that is that. If it is 2, case 2, what happened? So instead of saying if day is equal to 1, it's the same thing as case 1. If day is equal to 2, label 3 dot caption is equal to 2, it's the same thing as case 2, because we have made day the what? The case variable. So this should be Tuesday. Tuesday, you will get the same results. So now our day can be 3 as case 3. Case our day can be 4, that's case 4. And day can be 5, that's case 5. A day can be 6, that's case 6. There we saw if day is equal to 6, right? So here is case 6. Case 7, it can be 7, and 7 is Sunday. 7 is Sunday. and we have case else. Remember from the syntax, the same thing as else for if then. Do you get it? If then, else if else. That's if it's none of the above cases. That's case else. So I want my label to have the invalid caption, just as we wrote for the previous code. So invalid. All right. So now let's see. Today is Monday. You can see it's the same thing. So we can use if, then, else if, else, or we can use what? Select case structure. So if you have 7 or 8 should be invalid. You can see it's the same result with the previous one because nothing has changed. Do you get it? Nothing has changed except that I'm converting my if then else if structure to what? To a select case structure. So nothing has changed. So if I have 5, that's today is Friday, so I can clear. So there's no difference. So I think for selection structure, or some call it decision making structure. So that's everything that I think we need to understand for this class. All right, because programming is not what we can just take in 2 classes. So we have limited the scope of the class to that. Of course, you have so many other things in programming, but for this class, I've told us about the sequence structure, where your instructions are executed in sequence. I've told us about the selection structure, the structure that allows you to make a choice from several possible alternatives. And the next structure that I'll be looking at is what? Is the repetition structure, which I told us is the same thing as the what? As the looping structure. So looping allows a set of instructions to execute repeatedly. Looping allows a set of instructions to execute repeatedly. Just give me a minute. Let's check on those that are streaming via YouTube. Okay, so they are with us. They are fully with us. Right. So looping allows a set of instructions to execute repeatedly. Each repetition statement is by what is called the loop index. What is called as usually has a start or initial value. It has a step value and it has a stop or final value. So I personally call it SSS, which is start, step, and stop. Or we say start, stop, and step. So I call it SSS. Every loop index has what we call the start value. It has a step value, and it has a stop or final value. If you have been writing a program even in any other programming language apart from this, you would have come across this already. So the index begins with the initial value and must be incremented or decremented, right? And let's say the staircase has 10 steps. If I am on step 1 and I say take a step at a time, can you see? That means after step 1, go to step 2. Don't jump any step. Take a step at a time. After step 1, go to step 2, go to step 3, go to step 4, go to step 5, go to step 6, up to what? Step 10. Where did I start from? I started from step 1. That is my initial, right? What is my stop? It has 10 steps. Once I get to step 10, that is the end of the what? Of the staircase because it has 10 steps. That is my stop. And the step value that is talked about here is how do you move from the initial to the final? Are you going a step at a time or two steps at a time? Now let's go back to this. I have 10 steps. I'm starting from step one and I go two steps at a time. That means after step three, I said go two steps at a time. Step five, do you get it? After step five, step seven. After step seven, step nine. That is the step of two. If it is a step of three, from step one, I go to step four, I go to step seven, and I go to what? To step 10. So that is what we mean by start, step, and what and stop. You must start from somewhere. Your index has to start from somewhere. Then it must definitely have a what? A stop value. Then between your start or your initial and the stop or final value, you have what is called the step value. So in most cases, you can say, okay, just take a step at a time. That means increment by one. Or for someone coming down the staircase, you are at the highest step, step 10, and you are coming back to the what? To step 1, to the ground floor. So you take the steps. That means it's decrementing from step 10, go to step 9, go to step 8, go to step 7, up to what? When you get to the step at the base. So that's what we mean by it. So you can relate looping, do you get it, to something like that. So each time the loop is executed, the index is compared to the final value to test whether the loop to test whether to execute the loop once again. Don't worry, this might look abstract. We'll see how it is done in a program. So we have unconditional looping and conditional looping. Conditional looping is the loop keeps repeating until a particular condition is satisfied or met or broken. Do you get it? It keeps repeating. But unconditional means I already know the number of times I want to execute this loop. It's not the loop is not executing based on any condition. Execute this 5 times. That means you must have known ahead the number of times that you want that loop to repeat. That's unconditional looping. And for unconditional looping, an example is the for next statement. VB has the for next statement. The for next statement is an unconditional looping statement, which is used to know, which is used when you know in advance how many times the loop should be what executed. Remember, as I've always said, every programming language has its syntax, meaning that if you are going to use for next loop, this is how we want you to use it, which you can't change. Because once you are writing a program that does not conform to the syntax of that programming language, then it's going to give you an error. And once there's an error, that means your program will not, we have different types of error. That means your program has bugs. It's likely not to execute. And even if it is executing, it might be giving you a wrong answer. So when your program is not executing because you have not written it according to the syntax of the programming language, say you have what is called a syntax error. All right, and you can also have what is called the logic error. That means the syntax is fine, all right, but the program is not behaving as expected, meaning it's giving you a wrong outcome or a wrong output. So in that case, you say you have a logic error. So it's just for you to figure out where you have a wrong logic in your program and correct it so that the program can run correctly. And I think yeah, you also have a runtime error. That's the error you see. You won't, it's not syntax error. The program is fine, but the error does not happen until you run the program. So an example is maybe you are trying to divide by zero. You might not have noticed it in the course of your program. You say 8 divided by 0. The program will accept it because you have numbers. First, the numerator is a number, the denominator is a number. But normally, you can't divide by 0. So when you see this kind of, you might notice this kind of error when you're trying to run the program. So that is a runtime error. So think those are some types of errors that you can actually that you need to understand. So now the syntax for the for next statements. Remember we said we have an index which has a start value, a stop value, and a what? And a step value. So this is the syntax for that. For index equal to value 1, that's the start value. For index equals to what? This start value. So this value, that's my stop value. Step value 3. That means how should you increment the steps? All right. Increment the step 1 by 1. Is it 2 by 2? That means my value for step is going to be 2. If it is 1, it's going to be 1. If it is this, it's going to be so. That is that. For index equal to start value, so you cannot change it. Between the start value and the stop value, there is to, which must be compulsorily put there or placed there. And between value 2 and value 3, all right, there must be step. That's the syntax. You cannot change it. But however, that step is optional when the step is optional when I have a default step of 1. Do you get it? When my step is 1, I know that I want it to increment 1 by 1. So you might not put that step. So in that case, that step can be what? Optional. We'll see one or two programs to help us understand that. So now let's see this. Write a section of code in VB to count down from 10 to 0 and then print blast off. Write a section of code in VB to count down from 10 to 0 and then print blast off. Now look at this. We want to print 10 to 0. We can make use of a loop because when you have something, if you have a particular task that will be repeated, do you get it? A number of times. So you can just make use of loop for that kind of statement. Any If you have a set of statements or a single statement that will repeat a number of times, we can make use of loop for that statement. So, and we already know the syntax for our for next. I told you for index, your index is a variable, it can be anything. For index or counter or whatever you want to call it, for index equal to what? Start value. So stop value, step, this value. Put all your statements, and after that you have next index. So now we are printing from 10 to 0. That means our start, because it said countdown, our start is 10. Where are we going to? We are going to what? 0. Then after that, you print what? You print each value and you print blast off. So now let's see a simple code to do that. Let me save this. Create a my screen is full. Yes. Sorry. Can you hear me now? Okay. So remember I told you without our command button, nothing will be done. I have so many windows on this screen. So now let me call it do. Okay. So do, what's the code for that? I want to write a code. Now see, for index, I told you it's a variable name. You can give it any variable name. For index equals to start 10, or I want us to print 1 to 50. So let's write a code to print 1 to 50. You see that I won't say, uh, I won't just say label 1 dot caption equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You get it up to 50. You don't need that. There's a way you can write your code, because what you can observe from there is you are printing numbers and the numbers are increasing by 1. So what I can just do here is write the code to do this. Okay, so I want to print 1 to 50. I'm starting from 1, right? So where I'm stopping at 50. Step, how do I want to go? With a step of 1. That means the start index is 1 and I'm going to 50. But my step is 1, meaning that after 1, go to 2, go to 3, go to 4, go to 5, go to 6. Do you get it? Up till you get to 50. Remember I said immediately you write your 4. That variable name, what am I using? I'm using index. Put it, next index. And your code, your statements will come between 4 and what? And next. For index equals to 1 to 50, step 1. I know what is closing it is next index. So whatever is it that I want to repeat, do you get it? Comes within that for loop. So I will now say print. My index will first of all be 1, 2, 3, because I have step 1. So print index. So now let's run that and see. So run, do. Can you see? My window is small, so it's not showing everything. So let me increase the size of my window. So I've increased the size of the window. So let me shift my do to this side. All right, so let me run it. Do, can you see? It's printing 1 to 50. The window size is still cutting some values. Okay, let me make it 1 to 20 so you can see everything. 1 to 20. Click on do. You can see 1 to 20. It's printing 1 to 20. Now let me change the step. You see what we, oh, okay. So now let me change the step to 2. You said index is 1 to 20, step 1, so it's increasing by 1. The first index is 1. For index equals to 1 to 20, right? What this means is that I want to do something 20 times. What do I want to do? It's whatever I have in between 4 and next that will be done 20 times. And the only thing I have there is what? Print index. Print index. All right? That's the only thing that I have there. So I have print index between 4 and next. At first, index should be 1. It will print it. Step is 1. It goes to the next index. Index is now 2. It will print it. Goes to the next index. Index is now 3. It will print it. It keeps going until it gets to the what? The stop value for my index, which is what? 20. So now let's see. If I change the step to 2, what happens? The start index is 1. That means it will skip 2 to go to 3. Step 2. After 3 is 5. Now let's see. Do. Can you see? 1, 3, 5, 7, 19, 11, 13, 15, 17, 19. You see, this is as good as saying, if I tell you to write a program that prints, if I tell you to write a program that prints odd numbers between 1 and 20, can you see? That means I can just write a loop, 1 to 20. Step 2, it will print all the odd numbers between 1 and 20. If I say all the odd numbers between 1 and 50 is the same thing. Do you get it? It will print all the odd numbers that I have between what? 1 to 50. So that is that. Now let me, if I change my step to, okay, we have 15 minutes more. So if I change my, there's something now, okay. Now let's say I want to count down 20 to, let's say 1, 20 to 1. You see that my step is starting from 20. My step cannot be positive because positive means you are going up. So my step has to be negative, like 20 to 1 means it should be decrementing. So I can't say step 1. I would rather say maybe step minus 1. Meaning after 20, the next one will be 19 because it is coming down to 1. Do you get it? So now, if I have this, you can see 20, 19, 18, 17, 16, 15, 14. It's coming down up to what? Up to 1. So, what again? If I tell you that, okay, I want you to print all the even numbers from 0 to 50 inclusive or 0 to 20 even numbers, I can start from 0, 0 to 20. Since it is even, after 0, the next even number is 2. So After 2 is 4. So what that tells me is, oh, I think this is step 2. Then just say step 2. Okay, if I don't want to start from 0 because 0 is not an even number, I can say let me start from 2. So the first will be 2. After 2, 4. So now let's see that. You can see 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So this simple code that we wrote is as good as me telling you write a code that prints all the even numbers from 0 to 20. You can see there are 2, 4, 6, 8, blah, 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 up to what? Up to 20. So that is the essence of a loop. Instead of me writing print 2, print 4, print 6, print 8, no, with one loop statement, anything that you do that is repeating, do you get it? With your start, stop, and your step, you can repeat anything you want to repeat, any number of times. Okay, so you know what? Let me write a code. Before I leave here, let me write a code that prints the multiplication timetable of any number. Multiplication timetable of any number. Print. I hardly use print statement. I believe I most times make use of my labels and caption. Multiplication timetable. So let me see. There's something I want to see there. Okay, it's working. So print multiplication timetable. So it should ask us, what number do you want its multiplication timetable? Dim number as what? As integer. Dim number as integer. So receive that number in my input box. Number is equal to input box. Input box. I've told us how we can use input box. Yeah, I don't want to use my text box, or yes, I don't want to use my text box to receive an input. I want to use input box. We can use input box or text box. You see that on the form, I don't have any text box. So there is also what is called input box and message box. I can remember I mentioned both last week. I want to use input box to receive my input. So what number do you want to find? What number do you want to find its multiplication? Let me leave that as multiplication timetable, MTB. So what number do you want to find its multiplication timetable? So that will receive the number. So now, and I want my timetable is from 1 to 12. My index will be from 1 to 12. And I want to do that number that I entered, that number times 1, that number times 2, that number times 3, up to. So that number that is entered, because my index first 1, so it will be times 1 times 2, right? Next index 3, because it's a step of 1. Index will just be changing values by 1, but the number that 12 times 1, the first, because the first index, our index is starting Please, can we hear me? Oh, this is network. Okay. Yeah, thank you. The network, because I was disconnected. So, all right. So I said our index is starting from 1 to 12 with a step 1. So I want us to write a multiplication timetable. And you should ask us which number do you want to find its multiplication timetable. So you can ask, I want to find the multiplication timetable for 7. So what it should do is 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5. You get it? 7 times 6, 7 times 7, blah, 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 blah. So I want to write the code for that. My index is from 1 to 12. So that means if my index is from 1 to 12 and I'm looking for the multiplication timetable of 7, you should do 7 times 1. You should go to the next index 2, 7 times 2. Go to the next index 3, 7 times 3. Go to the next index 4, 7 times 4 up to what? 7 times 12. So I have written the code here, but I don't think there's an error here, but let's run to see if there's an error. Okay. So you can see, because I'm using an input box. Instead of me to enter the number that I want to find its timetable in a text box, I'm not doing that. I use the input box. You can see there's an input box on my screen appearing. Asking me what number do you want to find its multiplication 9. No, 9 because each index is 1. It will do 9 times 1, 9 times 1. Go to the next index, 9 times 2, next index, 9 times 4, 9 times 5, 9 times 6, up to what? 9 times 12. And 9 times 12 is 108. That's why we have the last value there as 108. So what if I'd wanted to skip? Now, I want you to see the importance of step. If I say step 2, okay, I have to close that. If I say step 2, meaning that the first index is 1, it will skip 9 times 2 because I said step 2. After 1, it will add 2, 3. After 3, 5. So it will do 9 times 1, 9 times 3, 9 times 5, 9 times 7. So let me put step 2 and let's see what happens. You see that the numbers will not be accordingly. So let me say 9. Okay, you can see after 9 times 1, we have 9 times 3. After 9 times 3, we have 9 times 5, 9 times 7, 9 times 9, and 9 times 11. It's not doing 9 times 12 because after 11, I said step 2, it's 13, and my stop index is 12. So that's why it's not doing anything beyond 12. Okay. So that is that. That's a for loop. Now let's go back to the slide. So now let me write a program to sum numbers. If you want to write a program to sum numbers from 1 to 20, you can as well do that. All you just need to do is how many times is this thing repeating? That's what will be my loop. Where is it starting from? I want to add from 1 to 20. That means I will have 1, 2, 3, 4. Okay. Those are my values. What do I want to do? I want to sum them together. So the simple code for that will just be something like this. I want to sum 1 to 20, so I don't need this again. I don't need this. I want to sum 1 to 20. So 1, starting from 1, that's index equals to 1 to 20. I'm adding 1 to 20, so my step is 1. All right. So what do I want to do? I want to add each of them. Okay, let's say there is a variable called so let's say dim sum as integer. Okay, let me give it a value. Sum equal to what? 0. So index will be 1, 2, 3, 4, 5, 6 up to 20. What I want to do is add each of them to what? To sum. So now let me say sum is equal to sum initially 0 plus index. Initially sum is 0. So the first sum will be what? 0 plus 1. Because index will be 1, is 0 plus 1. Next index will now be 2. It has done 0 plus 1, which is 1. That is the new value of sum. It will go again. Index is now 2. It will do 1 plus 2, 3. It has stored 3. My sum is now 3. It will go again. What's the next index? 3. And what's the last sum that I saved? 3. 3 plus 3, 6. It has saved 6. My new sum is 6. Next index 4. It will go again. Sum plus index 6 plus 4, 10. My sum is now 10. Next index is 5 because you have told it the number of times to repeat. It is 20 times and it must repeat 20 times. All right. So what is the sum of 1 to 20? If you use a math, this thing, n into n plus 1 over 2, that's 20 into 21, right? Over 2, that's 210, I think. That should be 210 or thereabouts. So now let's see. Okay, we have not. So now in the end, let's print sum. Okay, 210. Yes. So we have what? 210. That's the sum of 1 to 20. So if I want to say the sum is this, the sum is, remember we said we have what is called string concatenation. I think it's and. So now I want my statement to be more meaningful. You can see the sum is 210. So the sum is 210. You can see the sum is what? The sum is 210. So no, it's programming and you are just being introduced to it. So I just want you to understand how most of this how the syntax is for Visual Basic and how most of the control structures are used. So I believe that once you can go through it again in the textbook or you make your research, it is programming. We can't learn everything in this class now. Do you get it? So you still have to go back to your textbook, read your textbook, go online, just see how you can write a few programs. Do you get it and not? So that's one way you can actually get better. So this class is just going to introduce you to most of these things. How do you make selection? Of course, the syntax. If you have to work with it, you have to work with the syntax from time to time, so you can get accustomed or familiarize yourself with the syntax of the programming language. Even I myself, do you get it? Nobody knows it all, so you still have to keep learning. Just try to familiarize yourself with the syntax. But the class will expose us to how you can convert statements and all that to what to their VB to a VB program. All right, so let's see what we should be rounding off already because the last thing to treat in the course, even if you check your textbook, is the looping structure. So apart from that, we have a do loop. On conditional looping, we have looping with do loop. So it can be in any of these four forms. Do while logical expression, you have your statement loop. Maybe I'm trying to sum numbers of I'm trying to sum some numbers maybe to infinity, and I say keep adding the number. In as much as the sum is less than 210, keep adding. It will do 1 plus 2, 3. It's less than 210. It will add the next number, 6. 3 plus 3, 6. Is it still less? 6 is still less than 210. While this condition is true, do you get it? Keep repeating this. So do while, it will keep doing or executing the statement while that logical expression remains true. So once it is false, it stops. You see, that's why they called it what? This is conditional looping, not unconditional. Conditional looping. So you are stopping it with what? With a condition. Why this is true? You get it? Keep repeating this. So once it's false, it stops because that condition is no longer true. So it what? It stops. Do while logical expression. You've seen an example of a logical expression. That's maybe where you are making a decision that the value can either evaluate to what? To true or what? Or false. So once that logical expression remains true, it keeps running or executing those statements. And it can be in any of this form. We have do while logical expression, we have a statement, do loop. So that do is what? Is a keyword. While is a keyword. Loop is a keyword. It is called do loop statement. So we have do until, do this until this expression. Do you get it? So once that expression is true, it keeps repeating that expression. I think I have examples on the next slide that we can actually run. So we have do executable loop while. So we have this is called post testing. These two, you will see where the logical expression is. So this is post testing until this post testing. Here, before your statement is executed, this condition must be checked. That's pre-testing. Before your executable statements are executed here, the what? This expression must be what? Tested. But here, the first one would have been done. Do you get it? It would have done this. So while logical expression, now pre-testing, it would have done the first one, but for it to now do the second one, it has to check that condition. Do, it just entered the executable statement, it's doing it. But will I do it again? That's post testing. But pre-testing, before you execute those statements, you have to test before you can execute those statements. So now let's see examples. Write a section of code to add successive numbers starting with 1 until the sum is greater than or equal to what? To 0. You will see that here, we don't know the number of times that the loop is going to repeat. In unconditional, we want this to repeat 10 times, 1 to 10. For counter or index equals to 1 to 10, step 1 repeats 10 times. But here, we want it to repeat in as much as a condition remains true. Write a section of code. Write a section of code in VB to add successive numbers starting with 1 until the sum is greater than or equal to what? 1000. So what we did here is initialize sum to 0, num is 0, num is initially 0, sum is initially 0, sum has no value, num is 0. Now, do while sum is less than 1000, it is checking. Does sum have a value? Yes. Does sum have a value? Yes. It will only add num to sum. Look at this. Here, this is where we have the do while, the third line for this. This is where we have the do while, and this is where we have the loop. So look what are executable statements. We have this as the executable statements. Sum equals to sum plus num, and num equals to num plus 1. Those are the executable statements that we have in the what? In the do loop, do while loop. So now, look at that condition or logical expression. Do while sum, just English language, do while sum is less than 1000. Meaning that if my sum is less than 1000, do this. And do while means keep repeating. While, even if you get a new sum and it is still less than 1000, do this. While, so it keeps what? Getting the value of sum. And in as much as that value is less than 1000, it keeps what? Increasing or adding a new number to what? To sum. So I will add some print statements to this because yeah, there are no print statements. There are some things that I want you to see. So let's add some print statements to what? To this. So now let me copy. Okay, let's write a program. Let's write a program that does this. It adds successive numbers starting with 1, okay, until the sum is greater than or equal to 1000. Okay. Let me have a form. I have a button, so that still works. So just for me to keep adding now. Okay, so let's write the code for that. Let me clear this. So initially, it's to add from 1. We don't know where it is stopping. We don't know the numbers it will add together. But in as much as the sum of the numbers it is adding together is less than 1000, it keeps adding. So let's see the question again. Sorry. Or let me write it. So I don't want to be going back to the question. So add successive numbers starting with one until the sum is what? Is greater than or equal. So my norm is starting from 1. Yes, those that raised up their hands, any problem, you can reply via the chat. Any problem? Please, in the next 5 to 10 minutes, we'll be rounding off. So I don't. Yes, then there's something I still want to explain. How you would answer the questions in your logbook. So I think I need to explain that to us. So since there's no problem, so do while So while sum is less than 1000, keep adding. Because they said until the sum is greater than or equal to 1000. That means once it is 1000 or greater than, stop. But while it is less than 1000, keep repeating. So do while. So what happens? The new sum is what? Sum plus norm. So to do, what is sum? 0. What is norm? 1. 0 plus 1. So you have to tell your program how it will get to the next norm. So norm is equal to norm plus 1, meaning that increase my norm by 1. So once you have calculated the sum, increase my what? My norm by 1. That goes to the next number. Norm is 1. So when it increases norm by 1, it goes to 2. It would have added 2. Do you get it? 2 to sum. 2 plus this is still less than 1000. It would have a new sum. It will update the norm. It will increase the norm. Okay, norm is now 3. Okay. But the sum I calculated is still less than 1000. It will add that norm to what? To sum again. Okay, this is still less than 1000. It will increase the norm. Okay, and I now have 100. 100 is still less than 1000. So it will add that 100 to the last number is generated. Maybe it's giving 200. 200 is still less than 1000. It will add, because you said sum. What will be executed is sum plus norm. So it will add that sum that is calculated to the next number. Let's say 80, 280. That's the new sum is now 280. But that's still less than 1000. Okay, so what's the next number? 81. So it does 280 plus 81, 361. 361 is still less than 1000. So what's the next number? 82. 82 plus 361, 443. Do you get it? So that's how it keeps going until it now I've gotten 960. But 960 is still less than what? 1000. Okay, so let me add the next number. Oh, it's now 1001. No, I can't add anything to this sum again. So now let me do something. At every loop, I want you to see the value of sum and norm. So at every loop, so let's say print, after it has okay, print sum is. I want you to see the value of sum. Sum is. Okay, we have the ampersand for string concatenation. Sum is sum. All right, and ampersand, and norm is, and norm is. I have my ampersand. No. Type declaration does not match declared data. Okay, I didn't initialize my norm and sum. So dim sum, comma norm as integer. Where's the form? Do I have a form? Oh, close now. Like this system is hanging. me just copy my code so I can reuse it. Okay, then I use a text area. Okay, so I've relaunched it. It was hanging. Because all my windows are minimized, so it can't show everything on my screen. It can't show everything on the screen. Okay, so I have let me say a print button. Let me call it print. So once I click on it, okay, you can see it's working. Type declaration character. Does not match. Okay, okay, okay. So let me use string here. String of this. String of this. Okay. So now, can we see it's not showing everything? So can we see sum is 1? That it will do the first number I said is what? 1. Sum is 0 plus 1 is 1. So the next one is 0. So while that sum is less than 500, though if I want to show everything, I can just use a label. But I want to show it line by line. I can use a label to just print the sum, blah, 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 blah. So it will print this all the sum values for me. But I want you to see everything line by line because I want to print sum and num. So I want you to see everything line by line. So while that sum is less than 500, add the next number to what? To sum and print a new sum. So now let's see. I've reduced value. So now let's see. Print. Okay, so we can see everything. So initially, num is 1, sum is 0. So while sum is less than 500, is to check what is sum. Sum is 0. Is it less than 500? Yes. So to do sum is equal to 0 plus 1 because I initialized num to 1. 0 plus 1. That means sum is 1. Num is what? Num plus 1. So what is num? That means num is 2. Sum is 1, num is 2. Because my sum is less than 500, it will repeat that thing again. Because I said do while sum is less than, in as much as sum is less than 500, it will keep repeating that thing. So sum is now 3. It will do 1 plus 2. That is 3. Num is the next, because we've used 2. So the next num is 3. So it will do 3 plus 3 again, 6. The next number is 4. 6 plus 4 again, 10. And the next number is what? Is 5. Because 10 is still less than 500. It will repeat. Do you get it? Now look at this. In the end, as at 31, the sum was 465. When the sum was 465, the next number to add was 31. So it's checked. 465 plus 31, 496. That's my sum. But it is still less than. So to do sum is 496, 496. The next sum is 32. But since that 496 is still less than 500, so it will still enter that loop again. Because you said while sum is less than 500, it will still enter that loop. And 496 is less than 500. So it goes to the next sum. Sum is now 496 plus the next value is 32. 528. The next norm is 33. So it's now my sum is now 528 and my next number is 33. So 528, but 528 is not less than 500. That's why I didn't enter the loop again. If I had increased it to 700, let me close it. If I had increased it to 700, you see that it will go beyond 528. So if I had increased it to 700, it will go beyond 528. You can see it still got to 703, but it could not go into the loop again because 703 is not less than 700. You said while sum is less than 700, this is what I want you to do. Add the next number to my sum. But since 703 is not less than 700, so it could not even enter that loop again. Not to talk of adding the next number to sum or even printing the next number. So it is stopping. This is what is called conditional looping. So it is stopping because the condition is now false. While the condition was true, it was repeating by itself. You don't have to tell it a certain number of times to repeat, just as we saw in the case of a for loop. For loop, I want to repeat this number of times. One for index equals to 1 to 20. Step 1, that means repeat 20 times. For index equals to 1 to 50, do you get it? Step 1, repeat 50 times. So in the case of while loop, do you get it? Do while loop. So it keeps repeating until while that condition is false. So that is that because of time. I think that's the last thing that I have on the slide. Okay. So I can remember this. I told you VB has a lot of functions, so you can check some of these functions and how they are used. We have the SQR for the square root of a number. We have the STR. We have val, numeric value of a given text string, and a lot more. So I've used some of these already. Yeah, this string, it converts a number to string. I think I used it in this code. See, it's a function that converts a value to string. So I used it here because I'm concatenating a string. You can't concatenate a string to a number. So for it to get this number, I converted so that the number can be displayed. I converted the number to a string and I'm joining it to this string. All right. So in your logbook, you see that in your logbook, you've been told to answer 3 questions on the page one, okay, 130. Yeah, on page 134. All right. So write the program, exercise 1, the program in lab project 6. I believe if you go to page 133, you'll see that lab project 6. That's for a quadratic equation using almighty formula. So they want to calculate the two values of x. So in your logbook, you see that the first thing you have there is problem specification. What that problem specification means, try to specify the problem you're trying to solve. So write that problem to be as detailed as it can be. This is the problem I'm trying to solve. They have to write a VB program to calculate the values of x1 and x2, given that x is equal to minus b plus f. Do you get it? You are writing the problem, what you are trying to achieve, the problem you are trying to solve. That's what you have on that problem specification. Nothing more. After that, you have analysis. Your analysis, what they expect you to do there is to explain how you intend to solve that problem. Now, looking at the example that I just gave now for the quadratic equation analysis, for me to be able to use the almighty formula, I must have values for A, B, and C. Can you see I'm doing So the program should be able to ask you of A, B, and C. It will calculate X as follows: minus B plus minus square root of B square minus 4AC over 2A. If this B square minus 4AC is equal to 0 to give me this. So you are doing your analysis. That's how you intend to solve that problem. So the writing here is going to be more detailed. You are not just writing the problem. The problem you are trying to solve is your problem specification. What do they want to do? Write the question for them. That is the problem specification. Analysis, how you intend to go about it. And also for the analysis, one other thing they expect to see is your flow chart. That's a flow chart that matches with your analysis. You have explained to us how you want to work to solve that problem. So represent that your analysis as a flow chart. And of course, as we know, what is your flow chart? Your flow chart is a diagrammatic representation of how you intend to solve a problem. I will say it's the what? The diagrammatic representation of your algorithm. So what you're actually writing under the analysis is your algorithm, the step-by-step process or procedure on how you intend to solve that problem. So for your analysis, you have the detailed explanation of how you want to solve that problem, which is your algorithm, and the flow chart to solve that problem. Then for the design, that's the interface. We've seen a lot of interfaces. Let me just show us one again. So this is what they want to see. You can draw, I think they expect you to draw that. So let me see if I have, let me show you what an interface is. So the interface, the form, yes, there will be a label for this. There will be a text box for this. There will be a label to display this, display that, and all that. So that's what our analysis. So let me show you an example on my system. Okay. Yeah, I've already written the program here. So if you are doing your analysis, your interface, uh, this idea, this one that I wrote for a GPA calculator. So you can see I have a label, so that's the interface. I will have a label here. This one will display the value of my ID. You can see this, restart, exit. Those are my command buttons. I have a label. I have this label. This one will tell me to enter A. We draw the text input box or the text box beside it. B, enter B. You draw the text box beside it. Enter C, the text box beside it. X1 is equal to, you have a text box. X2 is equal to this, you have a text box. That's the interface. So the design, what they expect to see is the what? Interface design. And the last part, which is implementation, that's the code that is helping you to what to solve that problem. And when I say code, of course, we know what that means. That's something like this, the code that helps you to solve that problem. So we have spent the extra 30 minutes because I think we started by 8:30 while we were waiting for the link to circulate. So I think we have spent exactly 2 hours. That will be the end of your VB class. So I think the last chapter of this course will be treated next week by another lecturer. So VB is the only class that took 2 lectures from us. So I think with this explanation now, you already know what to do with your logbook, and a new date will be communicated to you regarding the submission. So the date for submission has been changed. So the new date will be communicated to you by your class reps. Okay. So before I call it a day, if you have any question, you can just ask via the chat. So I think we have come to the end of the class. Okay, so let me see if I have some questions. Yes, how to fill the logbook. I think I have described that already. Okay. Why did you use str sum instead of just sum? Joel Anuku. I used that because don't forget that your plus, we have different types of operators, right? So you can join, you can add numbers together. 8 plus 7, they are both numbers. So plus here is functioning as an arithmetic operator. Now that and is an operator. We call it concatenation operator. That's the ampersand symbol. Is a concatenation operator. It is used to join strings together. All right. And remember, we said the sum is. We have it in double quote. I said once you have your value in your double quote, that is a string value, and sum is an integer. According to that program that we wrote, sum is an integer. So I'm trying to join sum, which is an integer, with the sum is in quotes, which is a string. So for me to be able to join them together, the syntax I used earlier, I didn't put str, and it told me type error, that the types do not match. That's because it's telling me that sum is an integer and what I'm joining to is a string. So I should make both a string. So to just make that a string, VB has the str function, which is a string. So whatever value that you have in it, do you get it? It will just make it a string so that you can add it to something else. You can join it to another string. So that is it. Str is a string function in VB to convert its argument to what? To a string value. So that is that. Is flowchart under analysis? Yes, flowchart is under analysis. Yes, the flowchart to solve the problem is under analysis. But if there is no space, do you get it? Maybe if there is enough space or more than enough space on the design, just make sure it contains everything. All right. So the flowchart should be under analysis. If there is no space, then you can draw it in the. You just make sure that you have the interface, you have the flowchart, you have a detailed algorithm on how you want to solve the problem. You have this problem specification, and you have your implementation, which is what, which is the code. The date of submission has been changed, just as I mentioned. So let's see. Can we type everything out and attach it to the work instead of just writing? I would advise that you write, but the code might not, well, based on the questions that you have been given, the code should contain each the pages that you have. So I don't think you might need to, the questions they gave you are cheap. So you might not need to actually print anything. Do you fill with logbook with pen or pencil? I would advise pencil in case you want to erase anything. Flowchart, should we draw it under analysis on design? Analysis preferably, but if there's no space, you can draw it under design. How can we download the software? So you can go online, Microsoft Visual Basic 6.0 portable version. So just type that on Google, Microsoft VB portable version. Because if I tell you to go and download the Visual Studio, that might be. So just download the portable version, Microsoft Visual Basic Portable 6.0. So that's the one I'm using as well. You used some less than 700. If you used some greater than 700, this will not even work. Why? You initialize your sum to zero, and if you say while sum is greater than 700, that's when you want to do this. The sum that initialized to zero is not even greater than 700. So none of the executable statements will be wrong. That's the implication. You can try it. Nothing will happen. Except if you have a larger value than 700 and you are trying to decrease it. That while it's still greater than 700, keep doing this. Do you get it? So, but once that sum is less than 700, it stops. But based on that program that I wrote, if you leave, if you say why sum is greater than 700, nothing will happen. It won't run. Are we to draw the design house too by the grace of God? Can we print and attach to make our work neater? Lazy student, write. Don't go and print and attach. Write with your good handwriting. All right, so um, we have come to the end of the class. So thank you all for joining. And just as I said, the new date for submission will be communicated to your class reps. So thank you once again for your patience. Bye. Okay, the link for okay, I think you still have the link. Well, if you need the link for the videos, you can send your class rep to meet me in the Department of Computer Science so I can share the link with you guys. So in case you want to watch the video later for better understanding, the video will be there on YouTube. It's on the internet. So once you have internet access, you can even download and share amongst yourselves. All right. So thank you guys. See you. I don't know. I don't know when next I will see you. Bye. Stop sharing. Favor. Ifekuna, what's your question? If you are still online. Thank you. Bye.